The broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody. Thank you for joining us for the second running of our webinar today, which is the third webinar in our four-part series that will wrap up on Thursday of this week with a great walkthrough of some of the technological advancements in MRI lighting over the years. So that'll be a fun one. If you're not registered for that, I do encourage you to take a look on our website or look at your emails and respond to those so that you can join us on Thursday. But today, I, Chris Brownell, am joined by Logan Gerhard, our president, and the session we have for you is saving lives, saving money, and future-proofing facilities. And I know this sounds like a big title, so we're going to try to make it a little bit simpler. And we're going to talk about how lighting decisions in a hospital can be a clinical tool, an operational tool, and a financial tool all at the same time. So we'll talk about what works in real healthcare environments, why it matters, and what to look out for when you're specifying systems that need to meet stringent clinical requirements and that need to last for a long time, for decades in many cases, and they need to last for a long time at peak performance. They can't suffer major performance degradation over the years. So those three things that I mentioned, those are the big three things for today: clinical, operational, and financial impact. And if we're making the right decisions as it pertains to lighting, the value of those smart decisions can compound over time, because lighting decisions are more than just a single design choice. Lighting is truly a clinical tool within these care environments. It influences patient safety, it influences diagnostic accuracy, and it influences infection control. It's also an operational tool, impacting maintenance, downtime, and the optimization of workflow for your clinical staff, your facilities staff, your administrative staff, really all of the major parties involved in operating the hospital. And lastly, it's a financial tool. We have energy use, infrastructure load, asset lifespan, unplanned replacements. Those all tie directly back to lighting decisions that were made years before their effects are fully felt financially. And one reason this is also important is often overlooked, even by those of us who think about lighting every day. And the reason is this: lighting is embedded in the building. It sits above every patient, every nurse's station, every exam table, every MRI machine, like this one that's being hoisted through the open window by the big yellow crane here in the financial impact portion of the slide. And because lighting is integrated into ceilings and into infrastructure, the decisions that are made about what lights to put in will have an impact on the facility over 10, 20, sometimes 30 years. And we'll show you what that means a little bit today. So our theme is early design decisions have long-term consequences. We're talking clinical consequences, operational consequences, and of course, financial consequences. And the message that we're going to come back to a few times today is cutting corners up front to save money up front often becomes very, very expensive over time. We're going to focus on 4 topics today, and each of the 4 topics map to those clinical, financial, and operational impacts, as you can see on the slide. The first is infection control. Number 2, exam lighting. Number 3, energy use and operating costs and how that factors into sustainability. And then the big one, number 4, is serviceability and future proofing. And as we move through each of these 4 areas, just keep in mind, lighting will always involve aesthetic decisions in addition to those decisions we're discussing today. That's central to good design. But today we're intentionally looking beyond aesthetics, and we're going to treat lighting as infrastructure and think about it as a series of decisions and choices that directly impact patient care, daily operations, and long-term cost, often in ways that aren't immediately visible when the project is being designed or being built. If you want to hear more about marrying aesthetics and clinical performance in a healthcare setting, I encourage you to go to curlandlighting.com and watch last year's webinar on hospitality-inspired design in the hospital, which you can find on our webinar replay page. But the first focus area for today is infection control, and I'm going to hand it over to Logan to take us through that section.
All right, thanks, Chris. So let's dive right on into the role of lighting in infection control. So when people think of infection control, they usually think about protocols, hand hygiene, cleaning schedules, staff training, all of that matters, but infection control also lives in the built environment. Contact transmission remains the most common vector for spreading infections in a healthcare setting. That means surfaces matter. Lighting isn't just something behind the ceiling. It includes the trims, the nightlight faceplates, the wall controls, and anything that the staff and the patients interact with. Every one of those surfaces either supports a cleaning workflow or it creates friction. If a fixture has deep grooves, protruding fasteners, seams that could collect dust, or finishes that degrade under disinfectants, you've created a cleaning problem. And cleaning problems eventually become infection control problems. Lighting won't prevent infection control by itself, but it can eliminate places where contaminants accumulate. It can hold up to hospital-grade chemicals. It can simplify wipe down. It can avoid creating unnecessary airflow leakage. And when antimicrobial finishes are used, whether it's the silver-based product in Kirkland's BioGuard or a QAC-based, they are not a substitute for cleaning. They are an added layer of support. Infection control isn't just a clinical program, and it's certainly not a specification on a lighting fixture schedule. It's a workflow inside the hospital. Lighting either supports that workflow or it works against it. So we've talked about surfaces, and the other piece of that often overlooked is the air movement. Contact transmission is the most common route, but airborne spread is also plays a role in the hospital-acquired infections. Every recessed light fixture creates an opening in the ceiling. If that opening isn't properly sealed, if there's no gasketing, no IP-rated trim, no sealed housing, then you've created a pathway for air to move between the plenum and the room. And air doesn't just carry temperature, it can carry contaminants. So the goal isn't to eliminate airflow. Hospitals are full of controlled air systems. It's to avoid unintended airflow through fixture openings. The best way to do that is to use IP65 or IP66 rated fixtures, sealed trims, and even clean room rated construction where required. Different clinical spaces require different levels of protection. An ICU is different from a corridor, a procedure room is different from an administrative office, but the approach to infection control is consistent. If a fixture penetrates the ceiling plane, it should be sealed appropriately for the risk level of that space. So we've looked at how lighting interacts with the surfaces and the airflow. Now we want to talk about the consequences. Hospital-acquired infections don't sit neatly into one category. They impact the hospital across nearly every department and function. Clinically, they extend length of stay and increase patient risk. Operationally, they trigger isolation protocols, delay room turnover, and consume staff time. Financially, they have a massive impact. Treatment costs increase, reimbursement can be affected, and the operational disruption scales across the facility. And these three impacts do overlap. When a patient stays longer in the hospital, that's clinical, it's also operational, and it's also financial. So even small design decisions that reduce friction in infection control workflows can have compounding effects over time. Again, lighting doesn't eliminate HAIs, but it participates in the infrastructure that either supports prevention or undermines it. So we've looked at infection control, surfaces, airflow, and how lighting participates in all of that. But infection prevention is only part of clinical performance. The major role lighting plays is helping clinicians actually see. Chris is going to walk us through exam lighting and how it supports early detection and better clinical care.
Thanks, Logan. When we talk about exam lighting, and at Kirkland we talk about exam lighting a lot, we're really talking about clinical judgment. Providers are making decisions based on what they can see. Subtle changes in tissue color, bruising, inflammation, for example. If the lighting in the space distorts color or creates harsh shadows, that can affect the visual assessment, which in turn affects the care that's provided to the patient. And there are three fundamentals we want to talk about when it comes to clinical accuracy, depending on the proper exam lighting. And this picture I pulled from a health system in the Northeast that we do a lot of work with, and it's on their cardiac catheterization page. And I really hope that it's from their cardiac cath lab, which has Curlin Pro 45s as the procedural light, because then this illumination that this doctor is using to do the visual portion of his procedure here is a Curlin recessed motorized exam light. But the first of the fundamentals is color fidelity. You need accurate rendering of skin and tissue across the entire spectrum of light, but reds in most healthcare settings are particularly important colors. That's R9 if you're using extended CRI metrics. Number two, you need intensity and focus. Ambient light is not enough to perform a clinical exam. Clinicians require targeted illumination that reduces shadows and improves depth perception. And number three is consistency combined with adjustability, a little bit of yin and yang. Lighting should be predictable from room to room. That's the consistency, but it also has to adapt to the person using it. That's the adjustability. A 26-year-old resident and a 70-year-old attending don't need the same light levels, even if they're doing the same procedure. And different procedures also demand different intensities of exam light. So the ability to fine-tune your exam illumination, not just toggle between a few presets, supports both procedural accuracy and clinician comfort. Great exam lighting gives providers control without any variability in color rendering or performance. So what does this look like in practice? Well, here's a room that has recessed motorized exam lighting from Curlin, which we feel meets all the marks. First, positioning. The clinician can aim the light precisely where it's needed without rolling any equipment into the room or pulling down an overhead arm. Second is adjustability. Intensity can be fine-tuned based on the task and individual preference, whether it's a general assessment or a detailed exam. That adjustment can happen at the wall or at the bedside without interrupting workflow, just using Curlin's point of care controls, which you can see here on the slide, also known as the remote control and the wall station. Number three is integration. By recessing the exam light up into the ceiling, we're not adding another piece of equipment into the space. We're elevating the ceiling to support care. And we're making sure not to break the plane of that ceiling, as Logan talked about, from an infection control standpoint, because that's an IP66 rated trim. And finally, performance. Accurate color rendering and high levels of delivered light on task mean that assessments are consistent, not dependent on the room or the time of day. And this is exactly what we mean by lighting that supports clinical care and lighting that positively impacts clinical outcomes. So those are sort of the two arms of the clinical advantage between the infection control and the tremendous visual acuity that you get from well-designed, well-installed, perfectly specified exam lighting. So we've talked a little bit about lighting as a clinical tool, how it can support infection prevention and accurate assessments and procedures. But lighting decisions don't just affect patient care in the moment, they also shape how a facility can perform over time, also known as operational sustainability. And now I'll hand it back to Logan to walk through how sustainability can become more than a checkbox and really become an operational advantage.
All right, thanks, Chris. So on the topic of sustainability, I want to frame this the Curlin way, which is sustainability that actually saves money. When we talk about sustainability in healthcare, we really need to think beyond energy consumption. Lighting technology evolves. Efficiency improves, output improves, controllability improves. If a fixture must be replaced every time performance advances, that creates waste. Material waste, labor waste, and operational disruption. So one of the most important sustainability decisions is whether the product is designed to evolve. Our approach at Curlin has been modular, and we've been building modular systems for decades. We're talking about optical systems and electronics that can be upgraded without replacing the entire fixture. That means as LED efficacy improves, facilities can capture those gains without tearing out ceilings. That's what we mean by performance that improves over time. Historically, energy efficiency improves year after year, and we expect that trend to continue. With modular construction and durable housings, facilities can upgrade performance without replacing the entire fixture, without compromising clinical performance, and without generating unnecessary waste. So this is one of my favorite real world examples because it's sustainability that actually feels like sustainability. This is Sutter Health, Sacramento. About 5 years ago, they had a wood slat ceiling with 12-inch curling compact fluorescent downlights. Beautiful architectural ceiling, exactly the kind of ceiling you do not want to tear open. They wanted to upgrade to LED for the obvious reasons, better light, lower energy, less maintenance, but the constraint was clear. Do not ruin the ceiling. No disruption, no patchwork, no oversized trim rings. Because those fixtures were designed to be serviceable through the aperture, we were able to upgrade them cleanly. The ceiling stayed intact, the aesthetic stayed intact, and the facility gained better performance with lower operating costs. In the same photo, you'll see wall-mounted cylinders, good-looking housing, solid construction, but older light source technology. Last month, they reached out again to upgrade those LEDs. So at this point, you do not throw those cylinders into the dumpster, you upgrade the engines. That's modularity, that's sustainability, and it has been the Curlin approach for decades. And one more example from this same email chain, they have 170 dead front shower lights that are compact fluorescent as well, and they're starting to show their age. They're located in a tiled shower with a hard ceiling. That can be very difficult and can become a very big project. So instead, the retrofit plan is simple: to remove the trim, swap the light engine, refresh the trim aesthetics, all of this in less than 30 minutes per patient room. No ceiling reconstruction, no operational chaos. So the takeaway from this case study is real sustainability means keeping good ceilings and good housings in service and upgrading what actually changes, the drivers and the light engines. That's the kind of future proofing that meets the mark on clinical performance, operational workflow, and financial cost containment. So when we talk about sustainability at Curlin, we are not just talking about lumens per watt. We are talking about systems that improve over time. Energy efficiency matters today: lower wattage, lower maintenance, immediate operational savings. But sustainability also means being able to improve performance tomorrow. As LED technology advances, facilities should not be locked into yesterday's efficiency. And finally, sustainability requires serviceability. If you have to tear into ceilings to maintain or upgrade a fixture, that is not sustainability, that is disruption. Real sustainability protects operating costs, architectural integrity, and long-term adaptability. And the last piece, serviceability. This is where this conversation naturally goes next. So Chris is going to take us into how we design fixtures that are built to be serviced, upgraded, and future-proofed.
Thanks, Logan. So we've talked a bit about infection control, we've talked about clinical performance, we've talked about sustainability over time, but all of that depends on another critical question, which I've already sort of posed early on in the webinar, which is what happens to this facility 10, 20, or 30 years from now? Because in healthcare settings, buildings last for decades. And if you don't believe me, go to the hospital. You will see that technology changes and design preferences changes, and really a lot changes much faster than your local hospital's renovation cycle. So that means that if lighting systems are not designed to be serviced and adapted, then sustainability and performance both take a hit. So this final section is all about serviceability and future-proofing, as we said, and how we can utilize fixtures that evolve with the facility instead of being ripped out and replaced over and over again. So when we think about serviceability, we like to think about it as an operational advantage that comes from cost control. And because in healthcare, the most expensive part of maintenance is rarely the part that you are replacing. It's more so the man hours associated with the work being done. And even more than that, it's the disruption that the facility can experience as a result of the work being done. So if a fixture requires ceiling demolition to replace a driver, that means infection control protocols get invoked, containment needs to happen, after hours labor needs to get called in, and you're looking at room downtime. If you're in an MRI or an operating room, that can be tens or hundreds of thousands of dollars worth of downtime. And if a fixture is not modular, then a single electronic failure or degradation can turn into a full fixture replacement. So that means material cost, labor cost, operational cost, and opportunity cost. And at Curlin, our philosophy has been pretty straightforward for many, many generations. It's designed fixtures that can be opened, accessed, and serviced without disturbing the architecture around them. So drivers and ballasts can be replaced independently, light engines can be upgraded independently, and housings remain in place. That means a reduction in labor hours without incurring ceiling damage. And again, it protects that valuable clinical uptime. But there is more that we can do than just design for accessibility and upgrade. We can also optimize for frictionless maintenance and frictionless service. And I'll tell you a little bit more about how we can do that with a new offering from Curlin here in a couple of slides. But for now, let's just say that serviceability is not simply a maintenance feature. It is a cost control strategy and a life cycle enhancement strategy that's built into the design. And before I change slides, I just wanted to give a nod to the line drawing on the left here. That's Trash Truck, the titular trash truck from a television show for toddlers on Netflix that I find myself watching a lot these days. And that is where your light fixtures will end up if they are non-serviceable fixtures. Could be 3 years, could be 7 years, could be 14 years, but a friendly trash truck will be coming for your non-serviceable fixtures, and that will create a ton of unnecessary waste. So that's why we like to design, again, for accessibility and upgrade here at Curlin. So there's something else new that we're doing at Curlin, or something new. A lot of what I've been talking about, we've done for decades and decades, building fixtures for accessibility, serviceability, and maintenance. But the new thing that we're doing is something that we are adding to our spec sheets and our overall product offering because we think the industry needs it. And if you spend any time at lighting conferences, you'll know that this has been a buzzy topic lately as the first generation of LED luminaires are reaching their end of life and people are starting to ask questions about maintainability. So what we are doing is we're putting maintenance levels directly on our spec sheets. Many manufacturers will say their fixtures are serviceable, but that can mean just about anything if you lack a true definition. So we at Curlin are defining these maintenance levels very specifically. M1 means that the fixture can be serviced through the aperture with basic tools. Phillips head screwdriver, your hands, very straightforward access to the fixture and its internal components. M2 means that you need a specialty tool to open up the fixture. You almost always need this specialty tool for a reason. You may be in a behavioral health wing of a hospital where all of the fasteners have a center pin hex so that they can't be opened up by patients who we don't want to have access to what's inside the fixture. And so in those cases where you need a specialty tool, Curlin provides that tool, but the serviceability is still there. It just requires an extra layer to ensure that only the right credentialed people are doing the service, are accessing the fixture through the aperture. So we're adding a little bit more friction on the M2. We're doing it on purpose. And M3 means that the fixture requires some additional effort to perform that maintenance through the aperture, such as breaking a seal, removing anti-pick caulking around the edge of a trim, like we talked about in the webinar last week, just a slightly more involved process. So this maintenance level listing on our spec sheets, it's not about ranking products. It's not that M1 is better than M2. There are instances where M2 is absolutely the best that you can do with the requirements at hand for that room. So it's not about ranking, it's about transparency. If you are a designer or a end user who's trying to determine total cost of ownership, we all need a common language for maintenance complexity. And with these M levels, we're giving facilities teams and specifiers a shared language to hopefully come together and evaluate maintenance complexity before a specification decision or a purchasing decision is made. Because as we've said, it's so important down the line. And if we can know all about it up front, it will lead to better decisions and better outcomes. Another way that we can control cost and enhance serviceability is by isolating the electronics. This is what I was alluding to 2 slides ago, where we can take an already well-designed fixture that's designed for access and upgradability and make the maintenance even more seamless, even more frictionless. So in many fixtures, the driver and the control components sit directly above the ceiling inside the housing, inside the plenum. That means heat exposure, tighter service area, and more disruption when something needs to be replaced. With Curlin's remote mini cabinet approach, we're separating the light engine from the electronics, similar to what we do in our Symphony series for high ceilings and theatrical house lighting, if you're familiar with that system. The fixture remains clean and compact up in the ceiling or in the wall. The driver and the controls are housed remotely in a very accessible cabinet. That cabinet can be in a maintenance closet, it can be up above the ceiling. You can see here how it mounts very easily into a 2x2 or a 2x4 lay-in grid, which is very common in these healthcare settings. But what do we gain from that? What does that do? Number one, it simplifies service. A technician can access the electronics without opening a finished ceiling or a finished wall. This is particularly important in isolation rooms where everything is sealed to an IP65 or 66 standard. And it's also particularly helpful in behavioral health rooms where often fixtures are retained with tamper-proof fasteners and sometimes even surrounded with the anti-pick caulking. So the second thing it does is it reduces thermal stress. Electronics last longer when they're not sitting in a hot plenum cavity inside of a housing. And number three, we protect clinical uptime. Service is faster, cleaner, and less disruptive when you're doing that service here at the mini cabinet instead of directly at the fixture. So this is not just an engineering detail or a gimmick. This is another example of designing lighting systems around overall lifecycle complexity and lifecycle cost, not just the initial install. And we'll have a configurator on our website that shows how all of our fixtures that are going to be compatible with these mini cabinets map to the mini cabinets that you would use in a patient room or in an operating room or whatever clinical space you are illuminating with this new approach of isolating the electronics. So in healthcare construction, I mentioned this earlier, but I wanted to say it explicitly. There's a pattern that we see over and over, and that pattern is what we call the rip and replace model. Install a fixture, run it for several years, electronics fail or the industry moves on, efficacy is improved, so we open up the ceiling, we replace the entire fixture, we toss the old one in our friendly trash truck or in a dumpster, and then we repeat that cycle several times. And this is rip and replace. It's expensive and disruptive, and it generates unnecessary waste. But it persists in the industry because many lighting systems are not actually designed to be upgraded. So let's compare rip and replace with a serviceable system built on upgradable components. We install the housing once, and if you're talking about Curlin, maybe you installed that housing in 1980. You upgrade the light engine when technology improves. You replace drivers independently whenever needed. You preserve the ceiling, you preserve the architecture, you reduce waste, and you have the same clinical performance, or more often, even improved clinical performance as you go through these upgrades, but you don't have the lifecycle disruption and you don't have the additional operational complexity that comes from the downtime that we've already discussed. So avoiding this rip and replace, it's phenomenal for sustainability, it's phenomenal for waste reduction, and it's also phenomenal for the operational stability of the hospitals who rely on the lighting that we all specify and install. So that is what future-proofing means to us at Curlin. So we promised you in this webinar, we'd talk about saving lives and saving money. We also wanted to throw in saving time because that became very central to the overall narrative of what we're talking about here today. And if we zoom out from everything we covered, we want to focus on one thing, which is that lighting in healthcare is not simply about illumination. It impacts infection control, clinical accuracy, operational efficiency, and long-term cost. So we want to design our lighting thoughtfully and save lives by supporting early detection, reducing environmental risk. We want to save time by reducing downtime and simplifying maintenance and preserving that clinical workflow. And we want to save money by improving efficiencies, extending system lifespan, and avoiding that rip and replace cycle. So that's how we look at it and think about it here at Curlin. We're designing for performance today, designing for upgrades tomorrow, and designing for service and maintenance to happen seamlessly for decades and decades. Because as we mentioned, healthcare buildings last a long time, and we need to focus on lighting systems that are going to last a long time as well. So with that, I will open it up for questions. Sorry, I took us all the way to the top of the hour. I really thought we'd get through this one a little quicker. But if you'd like to ask a question, you may do so through the GoToWebinar control panel. I already saw a few come through as we were talking. So the first is, how do maintenance updates work for modules? I'm concerned about electricians having to solder wires and damaging or frying fixtures. That is a very good question. And actually on the spec sheets, we're adding, in addition to those maintenance levels that I showed you, we're defining what serviceability means in the specification area of the spec sheet at the very top. And in there we say, no soldering required, replacement parts will be shipped with quick connects. So that's essentially how we do it today. We have quick connects between the light head and the driver. And so if you are doing an upgrade or a replacement, you don't need to cut any wires, you don't need to do any soldering. You simply remove the quick connect, replace the new part, and plug in that quick connect with your two hands, and all is well. So there is, we've made it foolproof and simple so that we can avoid any of these challenges in the field that we know keep people up at night. The next question is, do you have experience upgrading fixtures to LED with new control systems, e.g. Dolly? Yes, we do. As a matter of fact, we've done some upgrades in Canada where we're actually going from Dolly to Dolly, but we're moving to a more modernized setup. And so we've done a number of Dolly-based retrofit kits. We've also done some interesting things with some wireless controls interfacing with Dolly, namely the Lutron Athena system, which is just one of several systems that will enable sort of the wireless communication of the Dolly protocol to the fixtures that are installed in the ceiling, and you can utilize that same technology when doing retrofits. So if you do have specific questions about control systems that are interoperable with our upgrade and retrofit kits, we understand that as controls have changed, that does increase sometimes the complexity of doing these modular upgrades. But with the new dawn of some wireless control capabilities, that's gotten a heck of a lot easier lately. So please do reach out to Curlin if you have those needs, and we're happy to assist. And we do have experience working with that to answer the question directly. Okay, the next question is, what fixtures are compatible with the new remote driver cabinet? So we will be listing over the next 3 weeks, probably within 3 weeks, on all of our fixture spec sheets that are compatible with the remote driver cabinet. You will see at the end of the spec sheet the way that fixture is compatible, essentially the map of how many fixtures a single remote mini cabinet can power and what that mapping looks like, what the options are. So you can see on this slide, we have remote mini cabinets for static white, dynamic white, which is either tunable white or warm dimming, our Hitsville task lights, night lights, RGBW fixtures that we are getting ready to launch. So there's a lot of mixing and matching that you can do. And as I mentioned, we're also going to have a configurator if you want to take a look at the way that those mini cabinets map to the individual fixtures. And lastly, if you go to the products search page on our website, I don't know if we've made this active yet. Yes, so if you go to installation type and you click remote driver, that will show you, right now it shows you our MRI and our Symphony series, as those are the only ones where we have updated the spec sheet with the remote driver option. But when we update all of them that have the remote mini cabinet, you will see this number of products will grow from 84 to probably over 184 that are fixtures that can be installed with a remote driver from this mini cabinet series. Okay, it looks like I have one more question. And the question is, what is the charge for a Curlin technician to go to the site to perform service? Can a general contractor or site facility team perform the upgrades? That is another great question. We don't generally provide Curlin technicians on site to do these upgrades. What we do is we'll manufacture the upgrade kit and put together a very straightforward installation guideline. And then we are sort of on hand remotely to answer any questions and guide the team through that upgrade. We also have the great support of our local lighting rep on site. So between Curlin back at the factory and our rep in the field, we've been able to successfully oversee, if you will, and facilitate all of the upgrades really that we've attempted. And it's as Logan mentioned with that shower light example, you're frequently spending less than 30 minutes in a room doing these upgrades. And once you've done one, the numbers 2 through 150, if you're doing a large hospital, are very straightforward. And these are frequently done by, sometimes you need an electrical contractor, you need a licensed electrician. There are other instances where an on-site facility team member, if it's at a hospital, can perform these upgrades, and that varies location by location. But in terms of the actual skills required, because of the quick connects and the very straightforward fasteners that we are using and the install instructions that we provide, it is pretty easy, and we do what we can to make it to answer any questions and give very clear guidance on what to do. And once you get rolling, as I said, you could start to do these in 10, 15 minutes per fixture. So it really starts to pick up speed as you go. All right, I think that is it for the questions. So the last thing is I will plug where you can find our webinar replays. So if you are interested in sharing this webinar or any from this 4-part series that we're doing this month, or last month and this month, the end of February, early March, if you're interested in sharing those, go to the webinar replays page in the Learn and Inspire tab on our website, and that will show you all of the webinars we've done in the past. We will be sending a recap after our final webinar on Thursday that includes the recordings of all 4 of these webinars, plus some interesting pieces of information that we've been asked for following on from these webinars from some of the attendees. So we'll be sending that out either Friday or Monday once the webinar series wraps up this week. So with that, I want to thank you all for attending this webinar today. And again, feel free to reach out if you have any questions at all about utilizing Curlin in these spaces. And have a great rest of your day and a phenomenal month of March. So thanks so much, everybody. Take care.